Turning a great idea into a successful connected product isn't just about building a working prototype. If it was, we'd have millions of more designs out in the world today. No, the real challenge starts when it's time to scale. When we're moving from that proof of concept on the bench to a reliable, secure, manufacturable product that's ready to be released to the masses. But in order to get started on the path to production, we need the right hardware, right software, connectivity, device management, and development tools, all working together from day one. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Erik Fasnacht from Digi and I explore how Particle helps engineering teams streamline every stage of connected product development. We investigate how Particle provides an integrated platform designed to simplify IoT development and accelerate time to market. And we also examine how building with production in mind from the very beginning can reduce risk, shorten development cycles, and help you deliver connected products that are ready for the real world. And before we get started, don't forget to click that link. There you can find even more information about this topic from Digi. Hi, Erik. Thank you so much for joining me.
Thank you so much for having me, Amelia, and thanks to the Mauser team for having the Particle team as well.
Absolutely. So we're talking about how we can get from prototype to production and build connected products with Particle. So talk to me about this.
Yeah, I think before we get started, I want to pose a question to the audience, which is, how long would it take your team to go from a working prototype to 1,000 devices deployed in the field? For most teams, the honest answer is years. Not because the idea is hard and not because the prototype doesn't work, but because everything between that working bench unit and a deployed fleet is a different kind of problem. So thanks for the introduction, Amelia. I'm Erik Fasnacht, a senior solutions architect at Particle by Digi. And I just want to say thanks to Mauser and Amelia for having me. Really, the goal of this presentation is to show you why that gap exists, why it takes multiple years to bring a connected product to market, and how do we close that gap.
Excellent. So, Erik, why exactly does this journey take years?
Because the moment you decide to ship a connected product, you've signed up to become an expert in a dozen things that have nothing to do with an actual product. You need RF and antenna design and getting a radio to actually radiate. You need cellular modem integration and the firmware to drive it. You need a cellular carrier relationship, or several, with SIM provisioning and data plans negotiated per region. You need regulatory certification, FCC, CE, IC for the radio, plus PTCRB and carrier-specific approvals before a network will even let your device on. Not to mention power management and battery life, security and key provisioning, and a connectivity stack robust enough to survive a flaky network in the field. None of that is your differentiator. Your customer doesn't care that you got through PTCRB or have this negotiated data plan. Every one of these is on the critical path, and any one of them can stall you for months. And notice everything I just listed gets you exactly one thing: a single device that connects. You haven't shipped a product yet. Now, multiply it by 1,000 units in the field, and a whole second category of problems open up. How do you provision and onboard devices at scale? How do you push a firmware fix to 1,000 of them safely, over the air, without breaking the fleet? How do you monitor device health, catch the ones that go dark, and manage data across regions? Behind all that, you're now running cloud infrastructure, ingestion, storage, routing, the security posture to keep it defensible, and the team to keep it running at 3 a.m. So you do what everyone does. You stitch it together. One vendor for connectivity, another for device management, another for cloud, glue code holding the seams. And what you've built is brittle infrastructure. Every integration is a failure point, every vendor a dependency you don't control, and every update risks breaking a connection 2 layers away. You didn't set out to build it, you can't easily change it, and now you have to maintain it for the life of the product. So here's our answer to all that in one sentence. Particle handles the complexity, so you build your product, not the plumbing. So I just made you a big promise, and the goal of this presentation is to back it up to show you exactly how we take the hard parts of IoT off your plate so you can focus on your product.
All right, so Erik, talk to me about how Particle simplifies application development.
Companies that choose our platform get to market faster, on average in 6 months or less. That's because there's one infrastructure provider, the Particle platform, handling the hard parts of IoT, security, OTA updates, it just works connectivity. That lets companies focus on the piece that's their actual product differentiator. I'll give you a quick example. Mamava. You've probably seen their lactation pods in public spaces like airports. They were facing a hard deadline to completely redesign their product, and at the time, they weren't on Particle. We took them from ideation to first production units in under 90 days, which highlights how quickly one can scale on the platform. And that's the pattern. 90% of companies that choose us successfully bring a Particle-powered product to market. So one infrastructure provider, zero IoT experience required from you, 6 months to market, and that 90% success rate. That's the shape of the promise, and the rest of this talk is the substance behind it.
All right, so talk to me about the different components of Particle.
Sure, so here's what one platform actually means. Particle is an integrated end-to-end IoT platform built to fast-track development of connected products. And it comes down to 3 pillars. First, hardware. Flexible and used across a huge range of applications, that hardware runs Particle Device OS, our firmware layer, the real-time operating system, RTOS, flashed to every Particle device that handles the edge compute. Second, connectivity, managed by Device OS and the Particle Cloud. We use an MVNO that provides connectivity across 350 carriers in 150 plus countries, so the device just connects. Here in the United States, our users have access to all 3 major carriers, AT&T, T-Mobile, and Verizon. Third, the cloud. Device management, secure endpoint, data pipeline, and orchestration all in one place. The key idea is the device you start with, prototype on, speaks to the same cloud and infrastructure your production fleet uses. And I'm not just going to tell you about this. I'll show it to you live before we're done. The actual console managing a real fleet in the field. But first, let me show you the full platform so you can just see how much of the stack it covers. And here's just how much the stack we handle. Top to bottom, edge to cloud. This is what you get out of the box, and almost none of it is something that you have to build. You don't need to build or stitch together infrastructure. You leverage features across the platform to put more value into your end product. Some teams care more about security and encryption. Others need a multi-radio product for redundancy. Whatever your application leans on, it's already here. Remember that brittle stack from a few minutes ago? This is the opposite. One integrated platform instead of point solutions held together with glue code.
All right, so I think I'm understanding the platform, but if I'm starting a design today, where would I start?
And the most natural place to start is with the hardware. The honest answer is you begin with a single board and the platform is built, so you never have to re-architect as you scale. That's this whole next segment. So here's the hardware portfolio, and the important thing isn't any single board, it's that they all share one device OS and one cloud. We have system on modules, our SOMs, designed into your own product for deployment at scale, the MSOM, our multi-radio flagship, the BSOM over LTE, and the P2 over Wi-Fi. We have development boards for rapid prototyping and proof of concept, Muon, which is the carrier board for the MSOM, Boron, which corresponds to the BSOM, and Photon 2, which corresponds to the P2. We also have ready-to-deploy gateways, modules, and an IP67 rated enclosure, Monitor 1 for equipment monitoring, and Tracker 1 for asset tracking. And at the high compute end, Tachyon, our 5G connected single board computer for Edge AI. Again, the takeaway is you pick where you enter based on what you need today, and you never throw away work when you scale.
Fantastic. Okay, so let's talk about the development board.
Most engineers' first particle device is the Boron, the familiar cellular workhorse in the Feather form factor. LTE-M connectivity with Cat 1 biz coming, and EtherSIM built in so it connects out of the box. No carrier negotiations, no SIM logistics, over 350 carriers behind one SIM. Think of Boron as your on-ramp. You can be publishing data this afternoon, and the firmware you write here carries forward to everything else in the portfolio. And where does that firmware go first? The M series. Traditionally, you picked one module for cellular and another for Wi-Fi, and then either deployed multiple SKUs or compromised on a single radio. That's where the M series comes in. The M stands for multi-radio. You have cellular, Wi-Fi, satellite, and LPWAN across the M series. To be precise, cellular and Wi-Fi live on the MSOM module itself. Satellite support is actively being rolled out in the M635E module, and LoRaWAN comes from the Muon carrier board, which I'll show you in a second. That means connectivity virtually anywhere, from a typical deployment on cellular and Wi-Fi, all the way to a monitoring product in the middle of nowhere on satellite or LoRaWAN.
So, Erik, you mentioned that board, the Muon, comes up a lot. So, there's a multi-radio development board as well, right?
So Muon is the development and carrier board for the MSOM, but it's more than that. It also adds LoRaWAN and Ethernet connectivity to your application. Muon uses the extremely popular Raspberry Pi 5 form factor, so you get a wide range of hats to minimize your development. Many customers use Muon as is in their product or as a reference design when they're laying out their own PCB. This is where we recommend starting. It's ideal for development and prototyping, and you can even deploy the product today using our IP67 rated M1 enclosure. This is the module behind Muon, the MSOM, our flagship MCU module. Almost everything you just saw on the dev board lives on this module. Cellular in multiple variants with the satellite-capable one, the M635E, in the process of being released. These are pin-for-pin compatible between the variants. Dual-band Wi-Fi, BLE, and GNSS. The two things that stay on the carrier board are LoRaWAN and Ethernet, and that's exactly the Muon's job. DeviceOS picks the radio connectivity automatically, giving you multiple redundant paths to transmit data in instances where one goes down. Here's the production path, which is the whole point of this talk. The firmware you wrote on Boron, BSOM, or P2 Photon 2 ports straight to the MSOM module on your own custom PCB. Same M.2 socket as the BSOM, and migration guides from each of our modules are available today. You're not re-architecting between bench and production. That's the year you get back. Everything so far has been about getting connected efficiently, but what if your product needs serious compute and intelligence at the edge?
So, Erik, we should also talk about Tachyon SBC, right?
Yes, and that's exactly where I was headed. Tachyon is the newest addition to the platform, and it's a product unlike anything else on the market. Tachyon is a single-board computer with native 5G and an integrated AI accelerator. Those two things on a single board are what make it unique. If you've ever needed both in one design, you know that until now, you had to piece it together yourself. Tachyon is built around a Qualcomm 6490 with a dedicated AI accelerator using 12 TOPS, purpose-built for edge inference. 5G and Wi-Fi 6 built in, no external modems to integrate. It's a credit card-sized, production-ready SBC in the Raspberry Pi 5 form factor, so it drops into the Pi 5 ecosystem and the accessories you already know. And it runs Linux, so it's a familiar toolchain and a faster first prototype. Same platform, same cloud, just a different class of capability when your product needs it. And here's what that compute actually unlocks. Tachyon does real-time vision and audio inference right on the board. Think cameras on the production line doing defect detection or audio monitoring on industrial equipment. The integrated AI accelerator at 12 TOPS is purpose-built for edge workloads. The processing happens on the device, not in the cloud, which means lower latency, less bandwidth, and fewer dependencies on a constant connection. The practical win is simple. Instead of streaming all that sensor data up to the cloud, you make the decision right at the edge and send up only what matters.
All right. So, Erik, what if your application is asset tracking? Do we even need to design hardware at all?
Exactly. For asset tracking specifically, that's what Tracker One gives you, ready to deploy out of the box. And it's not the only finished product we offer, but Tracker One is the product that fits this use case perfectly. Cellular connectivity with GNSS plus onboard sensors and an IP67 rated enclosure. It ships ready to deploy and is extensible using readily available M8 accessory cables. Provision and configure it in the console, mount it on an asset, done. Same platform, similar firmware model, zero enclosure engineering. So that's the hardware, from a dev board on your bench to a finished product in the field. But every one of these runs the same firmware and software, and that's the real story.
All right, so Erik, what about the actual code? Can we take a peek at that as well?
Absolutely. And here's the firmware story on one slide. Particle publish is the primitive. One line moves data from the edge to the cloud, encrypted over whatever radio the device has, cellular, Wi-Fi, or satellite. You don't write the transport. And this is literally the event you'll see in the console, environment data, with temperature, humidity, CO2, and particulate fields. The flash command below it pushes the firmware to your device over the air, no physical access required. That's the hardware story. But hardware is only half of what I claimed at the top. I also said that we take the cloud complexity off your plate, all those fleet and infrastructure problems from a few minutes ago.
Do you have any real-world applications you can share?
I do, and this is the perfect way to show you that cloud half, running for real. The fleet I'm about to show you is an air quality monitoring system deployed in several countries. This exact fleet is something you can look at live at any time by visiting particle.io/demo. The product runs on our BSOM, our cellular-only module, and it publishes data from the edge to the cloud. It uses two newer cloud features, Ledger and Logic. Ledger is used in three ways. First, it acts as a FIFO buffer. Second, it holds device-level configuration. And third, it stores threshold events for historical purposes. This is done by Logic, our JavaScript cloud function for adding cloud-based logic to your application. It reads each incoming event, checks whether the value is above a set threshold, and if it is, stores that event in a separate Ledger instance and fires an alert. These events are then routed to whatever backends and front ends you choose, either through our integrations, HTTP webhooks, or by talking directly to our cloud REST API. This is how many of our customers get more value out of the platform, using all the built-in features and functionality, with us as the secure data pipeline for your end application. With that context, I'll now show you the Particle console. This is the Particle console, the single pane of glass an operator actually lives in. Let me walk you through a real fleet. The first thing any operator wants: where are my devices? Here you can see the worldwide fleet of methane monitors using our BSOM module. Remember, this module connects over cellular, so how are we getting the position of the asset? We can derive the position in a few ways. First, we can estimate the position of the asset from the cell towers. The position of the cell towers are known and documented, which is exactly what we're doing in this demo. Another option is if the module has GNSS or you integrate GNSS capabilities into your application. You publish the position coordinates and they're displayed here directly. And finally, for more precise positioning, combine them: cell tower lookup, GNSS, and or passively scan nearby Wi-Fi networks to sharpen the fix. This is the platform feature called Location Fusion, shown live rather than described. Here you can see how accurate and precise you can drill down depending on what you're trying to find out about the fleet. For a moving asset, you can see its relative position over time with a breadcrumb trail to show the path. And once you can see them, the next question is, are they healthy? Now there are two ways to find this information. The first is the Fleet Health tab. Here's an overview of the entire fleet on one screen. By default, it shows a snapshot over the last hour. However, you can extend this view out to 30 days if needed. We also have various ways to filter the devices, either by device group, device OS version, or firmware version. But for now, we're just going to keep it at all. Here you can see the online devices shown as a count, 175 out of 183. what the cellular data usage has been over the given billing period, event traffic, how many publishes the fleet has had over the time range, integration traffic. We'll get into the specifics later in this demo. But together, event traffic and integration traffic give you a breakdown of pipeline health. This is your snapshot into how your fleet is performing right now. The other way you can determine your fleet health is drilling down on a particular device. So let's go back to our map. We'll pick another area, and we'll pick a particular device. Here's a single device page in the console where it's your one-stop shop for all data related to the device. Just like the map view, we have a mini map where the asset is physically located, along with general information about the device. Information like whether the device is online or offline, and when it was last heard and the last handshake occurred, what firmware the device is running, and what group the device belongs to. In addition, we also expose connectivity information about the device and what we call device vitals. The last data set from the device is exposed on the right. This includes network connectivity type used to connect. In this case, there's only one connection type, cellular, but on MSOM, for example, there are multiple paths data can take. It includes data fields like signal strength, signal quality, and what carrier the device is connecting to. In this case, it's T-Mobile. On the left, we have a live event stream, which is what we call events, which shows data actively flowing from the edge to the cloud and vice versa, and it's being displayed here in the event stream. Once an event is captured, you can click it and expand the data fields. And this is the exact publish, that single line of code with data fields we discussed earlier. Fields like the time, which is ISO 8601 timestamp in UTC, to temp, methane, and particulate readings. For this application, data is published every 20 seconds, but many applications need less frequency. That's the beauty of having full control of the firmware. This is the fleet monitoring problem from the start of the talk. These fields are the same fields as the last vitals tab, except now you have an historical view. And the best part is users don't need to develop any of this. Particle provides the secure endpoint, the event stream for data to flow, while also exposing device metadata for fleet management right out of the box. So now that you've seen some of the tools we built for users to manage their fleet, the next question you may have is, how do you know how this device is configured? Ledger exposes this data. This is how a device knows how to behave. To recall, we use Ledger in multiple ways for this demo. First, we use it as a FIFO buffer. And this is done by using a logic function to save the data. Here you can see the instances for the various devices in the fleet. And we use it as a historical look back as previous data transmitted. Now, many customers use this as warm storage to ensure data integrity, or use this data directly for setting up a digital twin. The other use of the ledger is for configuration, which in this case, we're using a device to cloud configuration. This is the base default configuration for the product, scoped at the product level. Every time the device connects to the cloud, it checks whether there's a new version of the ledger that needs to be downloaded, allowing for a fleet operator to change device behavior dynamically. In addition, we also have another ledger scoped at the device level for per device configuration. The final use of ledger is for capturing threshold events. This again uses a logic function, which we'll go over in a couple seconds, but this ledger captures the last peak event and the time it occurred. As I alluded to, ledger is being used in tandem with logic. So now let's take a look at logic. And this is the data doing something. Here you can see a logic function for putting data into the FIFO buffer, triggered by environment data event, and you can see it running on the live fleet. And here's another one for the threshold detector. Here you can see the JavaScript behind the threshold detector. At a high level, it imports the particle SDK, takes the data fields from the published event environment data, and performs some logic around the incoming data field for CH4. Once the incoming data is determined above the value, it then publishes the new event, including the threshold data. Both the FIFO buffer and the threshold logic functions are triggered by events, specifically the environment data event published by the device. But you can also schedule logic blocks to run too, instead of waiting for an event to trigger. That's exactly what we've done here with some of the other logic blocks. Here we have an offline device monitor, and it notes which device or devices are offline. And then we also have an integration monitor as well. And this runs every minute and looks at the data pipeline to confirm integrity. And the best part is, as shown with the threshold detector, these logic functions can create an event. So you can transmit the output of these logic functions to whatever endpoint you choose by using our integrations. And those events go wherever you need them to. Here you can see all the various integrations for this product. We track the name, something you input for tracking, event name that triggers the integration. Some of these should look familiar from the logic functions. Target endpoint for the data. Note multiple integrations for environment data, a backend, DynamoDB, and a front-end Loci dashboards. Whether the integration is enabled or disabled, and what today's traffic looks like. To add a new integration, it's as easy as clicking the button and finding the integration on the page. These are typically pre-formatted webhooks for various systems, and if you don't find what you're looking for, there's the ability to create a custom webhook shown here. This is the secure data pipeline point from earlier today, made concrete. The last feature I want to show you is how do you manage your firmware. Connectivity is core to an IoT product, and you shouldn't have to hold your breath every time you push an update to the fleet. Reliable in-field updates aren't talked about enough when starting an IoT project. This is typically the scariest, riskiest operation a fleet owner deals with, but with the Particle Console and the Particle Cloud, it isn't. In my opinion, it is the best and strongest feature of the entire platform. The OTA mechanism is secure, encrypted on both ends to prevent man-in-the-middle attacks. There are three kinds of updates the Particle OTA mechanism delivers. Application OTA, which updates the application or user firmware for new features, bug fixes, and improvements. Device OTA, which simultaneously updates the device OS and application, ensuring compatibility. And Asset OTA, which is one of our newer features, where it sends bundled updates to other system components, making the Particle device a central updater for its surrounding system. To start, it's as easy as uploading the file, which can include all three kinds or components as a zip folder, or the application and device OTA as a binary. Once it's uploaded, it then is shown as an option in this list. Once it is shown, the next step is to release the firmware. And then you can select whether it's the product default, every device takes a new update by default, or whether you want to select a group of devices before making it the product default. This gives you the ability to target which devices get the update, allowing for a smoother rollout to a wider production fleet. From there are two release options. How you roll firmware out matters as much as what you roll out. Standard, where the update deploys as devices reconnect. The update lands when each device handshakes with the device cloud, on reset or natural session expiration. Or intelligent, which deploys based on individual device readiness. This allows the firmware to mark the device as ready for update, versus it going out immediately to every available device. This is important as you may not want devices to take OTAs in the middle of a critical task. You can defer it until it's safe, or only take OTAs on a set schedule. An example is outside of business hours. totally configurable and customizable to your application. And that's the answer to the engineer's real fear. You never force an update onto a device at the wrong moment. Plus, the OTA mechanism has built-in retries and a chunking algorithm to ensure the entire update has been received before proceeding. So let's recap what you just watched. You saw a fleet of devices on a map locating themselves through cell towers, but this can also be GNSS and using nearby Wi-Fi networks. You saw their health and vitals at a glance. You saw real-time data streaming from the edge, the same event from the firmware slide. You saw ledger configuring devices and logic acting on that data automatically, then routing it to wherever you need it. And you saw firmware managed and rolled out over the air on your terms. Here's the part that matters. None of that required you to build or maintain any cloud infrastructure. No stitched together stack, no glue code, no brittle integrations waiting to break. Remember that brittle infrastructure from the start of this talk, the stack you normally have to build and maintain yourself? On Particle, that's all handled. You just watched it running out of the box. That's the other half of the year you get back.
There are a lot of different use cases that could utilize the power of Particle, right, Erik?
Yes, you're absolutely correct. And that flexibility is exactly why so many customers have selected Particle for their IoT product. Energy metering, healthcare, mobility, agriculture, supply chain. Every logo here is a team shipping a connected product on the same platform you just watched. Particle is built to scale, over 10 billion messages a month flowing through this infrastructure. And here's the part that should matter to you. Most of these teams aren't IoT experts and never want to be. They focus on their product and let the platform carry the plumbing. Plenty of them started exactly where you might be right now. One dev kit on a bench.
All right, so Erik, let's put this all together. Walk me through how Particle can take our designs from prototype all the way to deployment in the field.
Happy to. Stage 1, prototype and pilot. Boron or Muon. Muon in the Raspberry Pi 5 form factor, the full radio suite to test, Workbench, and Device OS. Stage 2, deploy to the field. Your firmware ports straight to the MSOM on your own carrier board, or you skip the hardware design entirely with Tracker 1. Stage 3, operate and scale. The console you just saw live with OTA, vitals, ledger, and logic. The same firmware, software, and cloud carry the whole way. Less complexity, one vendor, faster time to market. Remember, your goal should be to ship your product, not the plumbing. So a quick recap before we close. Asset tracking, Tracker 1, equipment monitoring, Muon and MSOM, along with Boron, Edge AI, and high compute, Tachyon. And the stat that's worth remembering, 90% of companies that build on Particle successfully bring their product to market. Everything shown today is available through Mouser, dev kits, SOMs, and gateways. Grab a Boron or a Muon to start. And almost every feature in the console is available on the free tier, so you can start building your application today and scale into tomorrow. Documentation at docs.particle.io will get you to first blink, and the live fleet you just saw is found at particle.io/demo, so go poke around yourself. That's everything. Thanks for watching, and thanks to Mouser for hosting. And with that, I'll hand it back to you, Amelia.
Awesome. Well, thank you so much for joining me, Erik.
I appreciate it.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Digi. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.